everyone, welcome. Happy you're all here. I'm happy to be at DevOps UK again. It's my second time. But this time the weather's really good. Last time it was like slightly so good. So today we'll talk about design patterns, and probably you're also wondering what the combination with the supermarket, like how is that combined? What are those two? How are those two related? But we'll get to that in a second. But first I have a really important question for you. Is there anyone who's never been in a supermarket? Okay, good. Everyone has been in the supermarket. That's great because the supermarket plays a really important role in this talk. So if you had no clue how a supermarket works, that was kind of tricky. So good, we have that out of the way. Still, before we go to the supermarket, let's dive into the design patterns. So what is a design pattern? If you Google it, you'll probably find a lot of different definitions. So I've combined some of the things that I think are relevant and to give you a definition that we will start from now. So first of all, design patterns don't give you code. I can imagine this sounds really weird, and some of you might think like, okay, then I'll leave. I'm here for the code. But no, of course, in the end, design patterns are about code. But they don't give you literal lines of code. So a design pattern is not something you can Google, copy and paste, and put in your application. It's more like a structure, and in the end, it will lead to code. So I said, like, it's more structure, and it's something for a common problem. So we all think we have really unique applications, but apparently we don't. A lot of the applications are similar, and they have similar problems. But the good thing about that is that they also have often similar solutions. So the design pattern is something that gives you a general reusable solution for a common problem. So something that we see in a lot of code bases. People found out that the solution worked every time again, and they found out that there's a structure behind that that you can use, even though that the implementation might be different. Because that's the thing from the design patterns, you can see it as a blueprint. It will give you a way of thinking about the problem, a way of thinking in a direction for the solution, but then still you can do the details that suits your application. You still implement it yourself, but there's like a guideline or idea behind it that you follow. So this is in short how I see the design patterns, and yeah, we will look in a couple of those design patterns today. But first of all, a little bit of history. So this is the idea, the concept, but they're now actual design patterns with names. So how did we get to them? So first of all, there was the Gang of Four. You may have heard from them. That's like the Gang of Four sounds really fancy, like some gangsters or so. They're just for developers or software people who found similar problems every time. And they thought, okay, maybe we write the solutions down. So they gave them names. They wrote down the characteristics, and that's how they created 23 design patterns. So they're divided in 3 categories: creational, behavioral, and structural. And no, we won't do all 23 today. Like, it will be a long evening. But at least you know there are more of them. If you're interested, you can read their book later on. But there are also tons of other books that require less. It's a tough book to start with, let's say it that way. And you might think 1994, that sounds like a long time ago. Or maybe it depends on your age, but I think for a lot of people it will feel like a long time ago. So are they still relevant? I mean, software changes fast. But the good thing is, because it's not actual code, it's about the idea, and a lot of those ideas still stand. And you'll see that some of the patterns are less used nowadays because the different way of how we look at software, but others are just, you can find them still in every code base. So why would you want to learn them? First of all, probably most obvious one, to learn about how to solve those common problems. Different ways to solve something or how to look at the problem. So first of all, it will just like deepen your architectural knowledge. But the funny thing is, also when I dived into those patterns, I saw a lot of the patterns you actually do know, but you just didn't know it was a pattern or had that name. Or sometimes it feels, at least for me, as like a common way to just for good software architecture or good software. But that's also the good thing. Some of the patterns feel logical. That's good, because it's more difficult if they feel really strange or really thought of. But still then, even if you recognize those patterns, it's really relevant to learn that there are in fact defined patterns, because it also gives you shared vocabulary with other colleagues. For example, if you're creating some code, you can just say, okay, I've used this pattern, I followed it. That's easier than just telling all the code that you've written. And it's also good to just check if there are any other details about the pattern you haven't thought about. Okay, enough about the design patterns. That's why we want to learn them. Let's go to that supermarket. Or not yet. We first have to introduce you to two persons. This is Bobby. And you might know Bobby if you know this meme from Bobby Little Tables. And Bobby has this friend, Billy. So today we will follow Bobby and Billie. And first of all, they're chilling on the couch. So it's Saturday afternoon. It's rainy, like normal England weather. And they try to use, or they want to use or watch a Netflix series. So they turn on the television. And just at that moment, there are some sounds on the hallway. And then the door is opening. And then there's the little sister from Bobby. She's only 4 years old. She's cute and annoying at the same time. And she has this note. And she throws it on the table in front of Bobby and Billie. And they're asking, like, what's that? She says, like, it's a note. Mommy gave it to me. And Bobby says, yeah, okay, but what's on the note? But she has no clue. Her mother didn't tell her, and she can't read yet, so she just knows she had to give that note. So then Billie grabs the note, she reads it, and it says, Bobby, please do groceries. And then there's a list of the groceries. So as you can imagine, they're not really happy with this request, because they're going to chill on the couch. But they now have to do it anyway, so they get up and go to the supermarket. Okay, there's the supermarket. But you might still be wondering, why are we listening to some story about Bobby and Billie? Because there's a pattern in every situation we'll dive into today. So what's the pattern we just saw in this situation? First, Mom wants groceries. And she writes this request, her ask or her question to the son on a note. And she writes what she wants and who needs to do it. Then she gives it to her daughter, and the daughter knows to bring it to the table. But the little sister doesn't know what to do with the note. But Bobby knows. He knows when he reads it, he knows how to handle that request. He knows how to get to the supermarket, what to do, and he can in the end do what his mother asked him via the note. And this was the pattern in the real world, but in the software world we would call it the command pattern. So the most important thing of this pattern is that it encapsulates a request in a standalone object. So what we see is the request was about doing the groceries, and all the information about it is on that note. So that's the command object. And this decouples the trigger of the request from the content of the request. So what we see, the content of the request, all the information, the little sister has no clue about it. She can't read it, it's all on that note. But she can still trigger it, so she can make sure that her brother will execute the request. So it's easy for the mother, because she can just give it and she knows it will be executed, and it doesn't have to be all at the same moment. She doesn't have to go to Bobby. So as I said, the invoker doesn't need to know the content. So here we see it a little bit more visual in the scheme. So we have the mom who's the client, and she could have gone directly to Bobby to ask him to do the groceries. But then you don't have the decoupling, and there are tons of other advantages that you miss because she has to see Bobby, he has to be available, and she has to. Okay. There it is. And it's gone. Okay, I don't know what it is with all the pointers today because there's so many problems with it. So the little sister, she doesn't need to know that the note is about doing groceries. So she get this command object, which is, I'm just keep trying, which is here on the right, and you'll see that there's an interface for the note or the command, and the little sister just has to know that mom gives her a command or a note. And she knows if I have that, to execute it, I just have to put it on the table. Then someone will react on that. But in the end, it is a do groceries note. And then Bobby knows what to do with it. So this object contains all the information. The interface only has the execute method. It defines that every command should have an execute. And then the do groceries node, that's the place where all the information is gathered and the actual request to the receiver is done. So here we see code. I'm not sure if it's readable in the back. It's more to give you an idea. So there's no constructors. This code is not going to work. But it's to give you an idea how it would work in code. So on the right we see node. Node is the command, it's the interface. It just has an execute. And then here we have the actual implementation who has the groceries list and knows who the receiver is and what to call on the receiver. But the good thing is for the little sister, she just knows it's a node. She only works with that interface. And she knows to execute it. Then mom, she has all the information. She knows the receiver and the groceries list. But the only thing she has to do is create that object with all the information about the request and then send it to the little sister, the invoker. And Bobby just has to execute it when it's called. So we see here is that at this moment, as soon as she gets the command, she directly executes it, but it doesn't have to be like that. It's just she will execute it, but mom has delivered it to the little sister, so that part is done. So a little bit more about the uses in the software world. What I just said is that the little sister doesn't have to execute it directly. So if like needed for your application, these are all details that you can decide yourself. So you can use the more basic one of this pattern and you can make it as complex as needed. So you can have a queue, for example, that the invoker gets it on the queue, or maybe she schedules it. But that's all things that you can do if needed. Same for reversible operations. So because all the information is in the object, you already have a lot of information about that step that's happening. So you can also put it on a kind of a stack of all the operations that happened. But the good thing to know about this is the fact that it's possible with the pattern doesn't make it easy. Reversing is still complex. You still have to know about state. You still have to know that you can go back. There's still tons of things you have to make sure. But it's something that you can use as a start if really needed. So now they're in the supermarket. And first they go to the vegetable department, then to the cheese department, and then they have a problem. They cannot find the coffee. So they go to the shelf where normally the coffee is, and there's no coffee at all. It's just an empty shelf. And they're looking around and they see that more people are like arguing and discussing about not having coffee. So people are panicking because they don't have coffee. And they look around and they see this employee. So they decide to ask him okay, hey, we don't see any coffee. When will it be back in stock? And he's really grumpy because people are all day asking him where the coffee is. And the thing is, he doesn't know. He doesn't know when the coffee will be back in stock. So he's so annoyed by all the questions all the time that he created this list. He created a list, and people can put down their information, and they will be notified as soon as the coffee is back in stock. So also Bobby and Billie, they write down their email address, and they can just continue shopping because they will receive an update as soon as the coffee is back in stock. So what did we see here? First of all, Bobby asked the employee when the coffee will be back in stock, but the employee doesn't know. And he's really tired of all those customers asking him again and again and again. So he decides to create this list where they can sign up and be notified as soon as it's back. So this is what we call the observer pattern. So the most important thing about the observer pattern is the one-to-many relationship. So we have one party with the state and a lot of others that can be interested. So in this case, you have the supermarket or the employee or like the place where the knowledge about the coffee is, and all customers that are interested. And when the state changes, the observers or dependencies will automatically be notified. And it gives you also loose coupling, because the supermarket doesn't need to know who are interested. So all the customers or observers, they have to have the same interface. They have to use that interface. And as long as they do that, the supermarket doesn't care how they will implement their actions when the coffee's back in stock. And they also don't care how many of there are. So that gives it more freedom for both the supermarket and the customers to work in their own way, as long as they have that interface. So what you see here is on the right we have the observers, who are the different customers, and then on the left we have the subject, which is stock update or the supermarket, and it has this register method. And they have to call it with an observer. So they can all call that endpoint and register themselves. Let it know hey, we're interested. And then nothing, they just wait. And then from outside, there's a call that says, okay, we got new coffee. And at that moment, the stock update will automatically call its notify observers. And it's as simple as that it will just go over all the observers that registered and call their update method. So in the interface from the observer, there's an update method, and it will just call it. And then it's up to the customers how they implement the observer or the update method. So maybe one customer wants to go to the supermarket directly because they need their coffee. And maybe someone else says, okay, I will just put it on my shopping list and I'll get it some other time in the supermarket. So that gives them the freedom to do it on their way. So what we see in code, we just talked about it. The observer interface just has the update method, and all the customers have to implement it. And the stock update itself, it has obviously its own state, and it has a list of observers. So people can register, but they can also remove themselves. That makes sense, because as soon as you have your coffee, either from this supermarket or another place, I don't want to be notified anymore. And then it will update the state as soon as the state or update. If the state updates, it will have to notify the observers directly. And I can't point, so I will do it physically. Here you will see that the observers do just for each on the list. And in that way, they will all be called. So what you see is that there's the objects I already said, like, they don't care about how many objects. Like, it's not even that they don't care, they don't know. So the update or the supermarket just has no clue. There's just observers, and it doesn't matter who is that actual observer and if they register or deregister. It's something that happens at runtime, and it can change all the time. And what's also good to think about, you have no control over who gets the information. So because it's everyone can register and you will just give them the information, you have to think about that. It should be information that's freely available. Of course, you can create all kinds of mechanisms, but the whole idea is that it's a state, and whoever registers can get the change of the state. So now we have only notified for the coffee. Let's go back shopping. But then they had another challenge. So now they're at the cookie department, and Billie saw these cookies and she wants them really bad. They're chocolate chip cookies. But Billie is a vegan, and she wants to know if those cookies contain any ingredients that she doesn't eat. So obviously she grabs the product, she turns it around to look at the ingredient list. But then the ingredients are in Spanish. So they're Spanish cookies, the ingredients are in Spanish, but Billie doesn't speak Spanish at all. And she's like a little bit stressed what to do now. But then she remembers she has a smartphone and it has a translation app, and she can just use it to translate the ingredients from Spanish to English. So that's what she does. She holds the phone, she uses that live function where it directly converts the image to a different text. And she's happy because she can eat the cookies. So what we see here is Billie wants to read the ingredients, but she can't read Spanish. So she uses her phone to translate it to English, and she can read English. So in the end, she's happy she can use the ingredient list from that product. This is the adapter pattern. And what the adapter pattern does is it looks at an interface which does not work with another interface, and then it solves the problem. It's like the glue in between. And it converts it to an interface that the client expects. So it's more from the client view. The client wants something in a certain way, but the server delivers it in a different way. And then the adapter is the part that solves it. And in this case, we saw it with things that really don't work together. But you can also use it to have a more generic interface. There are tons of reasons, we'll get to that later. So what we saw here, we have Billie. Billie is the client. And Billie could have used... I'm really stubborn, did you notice? Because I'm trying every time again. But sometimes it does work, or for a second. We have this Spanish product, and normally Billie can call it directly. But it has get ingredients in Spanish, and she doesn't know how to use that service. So then there's this product interface, which has ingredients as a method. And this is what we then can see as the client interface. So this is what the client would be happy to use. And then the adapter is responsible for combining those two. So it has to implement the client interface because the client should be able to use that class, and it has to do the actual translation. What we see here in the code is that Billie will just call get ingredients on product. She has no clue about the actual product that's underneath or the adapter. In the code case, of course, in the real world it was different. And then on the right you see that the product translator, that's our adapter, that's where most of the logic happens, because it has to call the service and it has to convert everything so it complies with what Billie expects. So as I said before, something about also a generic interface. For example, you're using a library. And then you use this library in your code. You use it all over your code. You use that really library-specific way of calling it. And then there's a vulnerability and you have to change that library. You have to go all over your code and change a lot of stuff to make sure you can use a different library that just have a different interface, different way of working. Also in that case, it makes sense to use an adapter. You can put the adapter in front of a specific library you're using, and you can give it a more generic interface. So you can make it more like, okay, get something from the database instead of the way that that framework works. So if you do that, it's easier to change the library and you only work with the adapter you create yourself because you know what you need from a library like that one. And it can also help you if you want to have a different part of shared code. So there's, for example, code somewhere in your whole environment you want to use, but you don't exactly like how it's working. Maybe it has this strange way of communication or an outdated way of the parameters, whatever, something about it that you don't like. Then you can still also put the adapter in between and say, okay, this is how I would use it, and there's only one place that knows how the ugly code works. So now they have the cookies, and last on their list is bread. Okay, that's great. They go to the bakery inside the supermarket. So they go there, go to the counter, and order bread. So what they get is sliced whole grain bread. They look at it, they feel it, and they're like, yeah, okay, it's bread, but they're not really happy with it because it's not, like the crust is not crispy and it's just fine for grilled sandwiches. So then Billy says, oh, I know this place, let's go there for better bread. So they go outside the supermarket is this French bakery. And they go also to the counter and they order bread again. But this time they get this baguette and it smells delicious and so crispy and they're really happy with it. So what we saw here is that they go to the supermarket bakery and they order bread. Next they go to the French bakery and they order bread. But even though they have the same question, the result is different. So based on the location, they get a different variant of the bread. And this is what we call the factory method pattern. In this pattern, the interface defines the creation of the product. So the interface says, okay, an object needs to be created, and it defines what kind of object. But then the actual creation is in the subclasses. So they're responsible for the creation, and they can also change the subtype. So as long as it's the same superclass as the one defined, they can change it. And this makes it really easy to extend. It's easy to add new subclasses. For example, with the bakery. If there's a new type of bakery, it can also implement its own way of returning bread, but then the bread that fits that kind of bakery. So here we see it again more visual. On the right you see the structure of the object type that is returned. So we have this bread interface, and in this case we have two subclasses, the whole grain sliced bread and the baguette. But as said, it can also be added more. And then on the left we have the bakery. So the bakery is an abstract class. You cannot go to the concept of bakery, you can only go to a specific bakery. But on this higher level, we define that factory method. So the factory method is create bread. So that there we define what should be created, which is bread. So this method is abstract and it needs to be implemented in the subclasses. So you see that the bakeries, they also have that same method. And the first one in bakery defines that it should create bread. And the ones below, they do the actual creation, and then they can return the whole grain sliced bread and the baguette. as discussed, we see here that there's bread and interface on the right, and so that's that whole structure again about the type of return. And they can have their own implementation of more methods, of course, but we didn't use them in the example. And on the left, you see the bakery. And this bakery has the create bread method, which is the factory method, but it can have more logic. So in this case, the order bread will do the creation of the bread or call it. And then the other bakeries, they do the actual creation. So it says, okay, bread, and they return whole grain sliced bread and a baguette. So the good thing is you don't need to know all the types beforehand. So if there's a situation where you know, okay, there can probably be more types, but I don't know about them yet, then this pattern might be handy, because you can have a lot of other logic that just works with the higher level and you works with create bread, and later on you can add different situations. And a completely different use case is the extension of a library. So if the library wants that and supports it, it can also give you the option to have your own bakery. So to create your own bakery, your own types, to make changes or have a specific part of that library work in a different way. So we left Bobby and Billie when they were in that French bakery smelling the baguette, and it made them so hungry. So they loved the smell of the bread, and they looked at each other and they were like, yeah, let's go for a nice sandwich. So they go to the counter again, and Bobby wants his chicken sandwich and Billie wants the vegetable sandwich. So they order those two different sandwiches, and then the baker prepares the sandwiches. So Bobby and Billie look at how the baker does that, and the baker seems to follow the same steps every time. So even though the sandwiches are different, the baker still follows a pattern that seems to be the same in a different every time again. So they see that the baker first gets a bread, it cuts it, and then puts a first layer, puts a second layer, and then the chicken sandwich, for example, has also a topping. But the vegetable sandwich does not have a topping, so that's something they see in differs. And then when it's finished, it's wrapped in a paper and it gives it to the customer. So they see that there's different sandwiches, but it's still prepared in a similar way. And it helps the baker because it's easier and it's faster to do it that way. So what did we see here? Bobby and Billie ordered two different sandwiches with different ingredients, but still the baker do it in a similar way, which is easy. And there are also optional steps, like that topping, which was only there for the chicken sandwich and not for the vegetable sandwich. So this is the template method pattern. The superclass is defining this skeleton. So in the superclass you say, okay, what's the process of creating a sandwich? But then the actual, like the steps in that pattern are defined in the subclass. Because the subclass is the part where it knows, okay, on the chicken sandwich I need to have chicken, and on the vegetable sandwich I need to have hummus and grilled vegetables. So that knowledge is just where it belongs. And then a superclass can have a default implementation. So for example, for that topping, we'll see it later in the code, that's easier, but it can have a default so that all the other subclasses don't have to implement it, but they can override it when they have a topping. So we see here on top is the sandwich, which is an abstract class, and it has this template method. So in this method, it defines the structure, it defines the steps. So that's the first responsibility, defining that pattern. But then also it defines some of those steps that have to be implemented by the subclasses. So in this part, we just see the add first layer as an abstract method. And then the chicken sandwich and the vegetable sandwich have to implement it. They know what is specific for their sandwich, so they have to implement it. And here in the code we can see it better that we have this method is the template method. So here we have all the steps. Here is defined how you should prepare a sandwich. The first one, prepare bread, is just the cutting of the bread, which is the same for every sandwich. So it can be just defined on the highest level. For things that are the same for every part, put it as high as possible. But then at first layer is different. So you have to put it on a lower level. So on the right you see the chicken sandwich and the vegetable sandwich. They both have their own implementation of at first layer. So they'll do it as the way it fits their sandwich. And then we talked about that default implementation for add topping. So the use case is you would say a topping differs per sandwich, or at least it can differ per sandwich. So we have to put it on the lower level. But the downside about that, what if we have 10 sandwiches and only 2 of them have a topping? Then all of the other sandwiches also have to implement the topping method, which is not like that convenient. So to solve that, you can implement or create that method already on the highest level and then set a default. So by default, we say no toppings. Most of the sandwiches don't have a topping, so we say, okay, no topping. And then for those couple sandwiches that do have a topping, they can just override the method. So what you will see is that the add topping, it's present here, and it's present in the chicken sandwich to add a sauce. But the vegetable sandwich does not have this method because it's not needed to override, because it's fine with the default behavior that's defined in the superclass. So what we see is that the good thing about this is there's less changes needed, that was a Dutch word, when the skeleton changes. So if there's, for example, a step that's for all the sandwiches. For example, if they say, okay, now we also want to give them a discount voucher, then we just add that step on the superclass. No changes needed on the other sandwiches. And of course, if you have a step that should be implemented by all the subclasses, then you still have to make the change in all the subclasses. So it's easier for you to do that, but it also forces a structure. So no one can create a new sandwich and then forget to do all the layers. Just put only a topping. That's just not possible. If you implement it, you have to override those abstract methods. So you have to comply with that structure. So it also helps you to guide that all the sandwiches are created in a similar way. So they had their sandwiches and they were really good. So now have their bellies full, the shopping bags full, and they head home. So they're looking really forward to watch Netflix again or start watching Netflix. But then mom doesn't agree because they dropped the bags on the floor and they went to the couch. But mommy is like, no, please put away the groceries first. So they're not happy again. They roll their eyes, but they know they shouldn't argue with her. So they went to do it anyway. And 5 minutes later, they put away all the groceries. So they put away everything in the correct space. So first of all, they had to take the groceries and then look, okay, what should be in the refrigerator? What should be in the cabinet? Where to put everything? And then also not only where to put it, but how to put it there. Maybe there are specific things that need to be thought of, like the older product in front and the newer in the back. So they did all of that, and then they were finally allowed to go chilling. So what we saw here is that mom gives one instruction. Please put away the groceries. That's just it. And then Bobby and Billie put everything in the right place. And mom doesn't give the instructions to say, okay, but I want the milk on that spot, and I want this there, and I want it in that order. She doesn't give those instructions. And she also doesn't really care. She doesn't need to know about all the steps that are taken by Bobby and Billie. She just cares about the end result. So this is what we call the facade pattern. And in this pattern, you think really from the client. So you create a more simplified interface for the client. The client just wants to say, in this time the mom wants to say, put away the groceries. She doesn't want to know about all the other details. So she doesn't need to know about what we call the subsystem. So in this case, the subsystems are all the different places they can put the groceries. And she doesn't need to know about that they exist and how to handle them. So it removes a lot of complexity from the interface for the client. So for the client it's easier and the logic is on a different place. What is really visible here, because mom is on top and the only dependency she has, or the only thing she has to call, is Bobby. She only has to call Bobby, the facade, and say, put away the groceries. And then below you see like the subsystem. And the only one who needs to know about is Bobby. So he knows how to call all of them and how to work with them. And also here it's visible again that on the left we have mom. And mom just knows the facade and call, put away the groceries. And then Bobby should even be a longer class, but then it didn't fit the sheet. So there's also the filtering, like, okay, how does he know what should be where? And now it will just be like the different parts of the subsystem and call it. But probably those subsystems have different methods. Maybe you have to do some conversion before you can give them the products you have. So all that logic should be in the facade. And now, of course, we had this really real-world example, and subsystem is maybe a little bit big for something like the places to store. But something you can also think about, what probably makes a lot of sense, is home automation. So you come home and you say, hi, I'm home, and at that moment your favorite song is playing on the right volume. Maybe your meal is being prepared in the oven, like it's heating. Maybe the temperature of the room is set differently as soon as you're there. Like whatever you can think of, you can combine that with like the sentence, hey, I'm home. So also there you see that the home automation is your facade. So I come home, I'm the client, and I don't want to say, okay, turn on Spotify, turn on the stereo, turn on that song on that volume, then I want that, then I want that. So they're all steps I need to take just for the song part. And that's just a couple parts in that subsystem. So that's also a really good example of how to keep away all the complexity of the subsystem from the client and make it easy for the client and hide that logic. And now we saw just a facade with a subsystem, but if it can be really complex, you can also have multiple facades. Maybe even for that home automation, just to get the idea, you can say, okay, I have another facade in front of everything that has to do with sound. Maybe if you're completely into music, you have like 5 different things you can control with all different requests you have to send, and you say, okay, there's another facade that's just responsible for that. And they can just then call with the other facades instead of directly. So this was already the last design pattern that we were looking into today. So I thought, okay, let's go over them real quick, so you have them still in mind. But before we go to that, I want to say, now we really looked at those design patterns in isolation. So to make it better understandable, to really look at that design pattern, we try to find situations that have exactly what matches the design pattern. But in your code, you will probably have a more complicated situation that needs multiple design patterns, or also need different things. Because the design patterns are not complete. They're really focusing on one part. Like, you shouldn't see them as a complete solution, but they have a an ideology for that part, and it doesn't mean that everything around it is solved. If you think about the bakery, we said, okay, so the different bakeries are responsible for creating a different object. They know what kind of objects should be created. That sounds brilliant. You like leave them up to it, and then we have the bakery. Okay, but if you want to use this in your code, how do I make sure, like at some point I have to decide which bakery I'm using, like how am I going to use that? How I'm going to solve which bakery instance to use in the code. But that's out of the scope of that pattern. So that pattern is looking at a certain problem, and maybe you use another pattern to decide which bakery to use. So in this case, it was just a client who thought, okay, I want to go to the bakery. So you'll see that when you go to work with the patterns in your code, they're not silos, they're working together or need more than just that pattern. And also, I hope that it works also for you to see it in a more visual way or to combine it with something in real life. So if that helps, try to do it with more things. You don't have to go search for situations in a supermarket and go drawing, but you can also think shortly do I have something that's familiar, or do I know the code example? It really helps you to get those ideas stick. So first of all, we had the command. And the command was about really encapsulating all the information in this standalone object. That's the core of the pattern, that the information is in an object which you can pass around, and that gives you a lot of flexibility. Then we had the observer, where people would ask the employee all the time about his state. And this is all about the concept of don't call us, we call you. The observer doesn't want to be bothered all the time. It will call its dependencies when something changed. The adapter is about having something in between incompatible interfaces. So we have a service that provides something in Spanish and a client that expects it in English. So the adapter solves that. The factory method is about the bakeries, where a different bakery has a different type of product. So as we just discussed, they create what suits their situation. The template method has a superclass in where the template or structure is defined. It defines all the steps that are needed for a process. And then the subclasses are responsible for the actual implementation of the steps that suit with their kind of product. And last we saw the facade. And this facade was about making everything easier for the client. So making it for the client as easy as possible, and then hide the complicated things from that subsystem. So we had only 6 of the 23 patterns. So I encourage you, go to the supermarket and try to find them all. And I'm sorry if this ruined your relaxing shopping experience. But if you ever find one in the supermarket, just send me a message, because that would be really funny for me if you find the design patterns there. So that was it. By the way, this is me. My name is KAYA WEERS. I work at Ordina. This is how you can contact me if you have any more questions or anything else. And here you can find the slides, like if you saw some people taking pictures, but if you want them, you can have them there. So thank you.